Hi students, in this video I would like to discuss about hybridization. So let us see what is the definition of hybridization and purpose of hybridization. Okay? Yeah. So let me define hybridization like this. Intermixing of atomic orbitals is known as hybridization. Intermixing of atomic orbitals is known as hybridization. We know that atoms are composed of orbitals, s orbital, p orbital, d orbital, f orbital, and so on. Okay, when these orbitals combine together, they will produce hybrid orbitals. The process of getting hybrid orbitals is known as hybridization. Then what is the purpose of hybridization? Why the hybridization should happen? So when hybridization happens, molecule will get stability. Not only that, by using hybrid orbitals, we will be able to explain bond angles, geometry, shapes of the molecules. That's the purpose of hybridization. Okay, so we have different kinds of hybrid orbitals in chemistry. Suppose, let me give examples. sp hybrid orbital, sp2 hybrid orbital, sp3, sp3d, sp3 d2, sp3 d3, and dsp2. Okay, so these are the hybrid orbital we will find in chemistry. You take any molecule, that molecule should comes under any one of these hybrid orbitals. Got it? Yes. Now my focus is I am not going to discuss how these hybrid orbitals are formed. In chemical bonding chapter, there is a clear-cut explanation. So quantum mechanics clearly explains how these hybrid orbitals are formed. I am not going to discuss anything about quantum mechanics. Just I would like to give a small tips to find out hybridization of central atom. In general, central atoms only undergoes hybridization, not surrounding atoms. Okay, so in order to find out hybridization of central atom, what are the tips? By using tips, how you can find out and predict the hybridization of that atom. Got it? Suppose let me take carbon here, carbon in the center, and surrounding atoms are hydrogens. Central atom is carbon, surrounding atoms are hydrogens. Only carbon undergoes, because carbon is the central atom, central atom only undergoes hybridization. Okay, so what is the hybridization of this carbon? Okay, so before finding hybridization of this carbon, let me give two tips. What are those tips? Tip 1. Tip 1. Hybridization equal to number of sigma bonds plus number of coordination bonds plus number of lone pairs around central atom. So tip 1, hybridization equal to number of sigma bonds. This is the symbol for sigma, Greek letter. So number of sigma bonds plus number of coordination bonds plus number of lone pairs around central atom. First you should know these things, whether these are available in the molecule or not around central atom. Tip 2. So maximum 1 s orbital involves in hybridization. And 3 p orbitals involved in hybridization, and 3 d orbital involves in hybridization. Got it? You take any hybridization, in that maximum how many s orbitals you can find? 1. Maximum how many p orbitals you can find? 3. And 3 d orbitals. These are two tips you should remember. Very easy. So hybridization equal to number of sigma bonds plus number of coordination bonds plus number of lone pairs around central atom. So maximum 1 s orbital, 3 p orbitals, and 3 d orbitals involves in hybridization. That's it. So let us see hybridization of the carbon in methyl molecule. So around carbon, how many sigma bonds you have. Single bond is there means the single bond will be called as sigma bond. So 1, 2, 3, 4. So 4 sigma bonds you have. And how many coordination bonds? So there is no coordination bond, right? So there is no coordination bond. So 0. Plus how many lone pairs around carbon? There is no lone pair. So 4 plus 0, 4. Number is 4. So number is 4 means we should take 4 atomic orbitals. 4 atomic orbitals to get hybrid orbital. Okay. So how many s orbitals can be taken maximum? 1 s only. Okay. So among 4 orbitals, I have taken 1 s orbital. Remaining 3 will be p orbitals. Remaining 3 would be p orbitals. So 3 p orbitals, 1 s orbital. So total hybridization would be sp3. So therefore, in methane molecule, carbon undergoes sp3 hybridization. Very simple. Got it? So let me give one more example also. So let us take here. Let me take a simple molecule, sulfur dioxide. Sulfur dioxide, SO2. This is how the sulfur dioxide molecule exists. Okay, so now the central atom is sulfur here. So let us find out hybridization of that sulfur. Okay, so let us count number of sigma bonds. How many sigma bonds around this sulfur? This side one sigma, this side one sigma. Double bond is there. This side one double bond, this side one double bond. So double bond is there means one will be sigma, another one will be pi bond. You don't have to worry about number of pi bonds. Just count number of sigma bonds. So one will be sigma. This side one sigma, this side one sigma. 2 sigma bonds are there, and there is no lone, there is no coordination bond. Sulfur is not forming any coordination bond. 0 coordination bonds. And how many lone pairs are there? 1 lone pair. So what is the number? So 2 plus 0 plus 1. Number is 3. Number is 3. Okay. So when number is 3, how many orbitals can be taken? So maximum 1 s orbital can be taken, and remaining 2 would be p orbitals. sp2 hybridization. That's it. So if you know these two tips, by using these two tips, you will be able to find out hybridization of central atom in any molecule. You take simple molecule, complex molecule, tough molecule. So in any case, if you remember these two tips, just you will be able to find out hybridization of that central atom. That's it. I hope this video will be useful. So thank you very much for watching.